you that don't know Hadyn, he is the CEO of Oxitec, a British company that's trying to fight malaria, Zika, dengue, chikungunya, and all this with genetically engineered mosquitoes. But let's hear it from Hadyn himself. Could you explain how this technology works?
Sure. Well, I think we'll start with the problem first, which is that over the last 50 years, you would assume that as mankind becomes more wealthy, as science advances, that we become better at controlling mosquitoes. And you would think that the number of mosquito-borne diseases would go down. And in fact, that's the wrong assumption, because every year mosquito-borne diseases are going up. They're actually causing more problems every year. And the problem really is that urban mosquitoes will live inside people's houses. Here we are in Berlin. If we were in Sao Paulo, then half of the mosquitoes that would cause damage to children, to adults, would be actually living in people's houses. So unless you can get into people's houses every day as a public health official, which is obviously impossible, you really can't control mosquitoes in an urban environment. So we've taken a different approach. We're not using chemicals, we're using the mosquito against itself. So every mosquito that has ever bitten you is a female. And so what we do is we release males, which don't bite, obviously. These males will go out, they'll do what males do best, which is they'll find females wherever they are, they'll mate with them, and then actually the offspring will die. So we have a self-limiting gene, which is in all the males. We release the males, they fly out, they find females, they mate with them, and the offspring die. And the more males we can release, the more they'll mate with the females, the faster the population will come down. So to come back to insecticides, the best result you'll find really anywhere in the world in terms of controlling an urban population of mosquitoes is about 35%, meaning with all of the various different chemistries combined and using different traps and fogging and spraying, you can probably reduce the population of mosquitoes in a town by about 35% if you've got a big budget. With our mosquitoes, in every single trial we've done in urban environments, we've reduced the population by over 90%. So it's a massive shift in terms of efficacy. We combine our approach, which is obviously an effective one, with all our mosquitoes carry a fluorescent marker, literally a colour, so that you can monitor them. You can see where they've gone, you can see how far they've flown, you can see how successful you're being. And then we're also backing up the monitoring with an app to make this more useful and friendly for the vector control authorities in each town.
Okay. So have you already tested this app and this release of the mosquitoes?
Yep, so we've started doing trials since 2009. 2009 was our first outdoor trial. So if you like, before then we were sort of preclinical. In 2009 we did first trials in Cayman, we then did trials in Panama, Brazil. We've now got to the stage where in Brazil we have national biosafety clearance, which means we can release our mosquitoes anywhere in Brazil. And then we've actually started commercializing this as well. I mean, regulation is always an interesting question, which you may or may not ask me later, but we're actually now commercially applying our mosquitoes. So if we were all in a town called Piracicaba in Brazil, every now and then you'd see a little van going down the road. Every few hundred yards you'd see a little puff coming out the window. And actually that's 1,000 male mosquitoes being released. And the person inside the van is sitting there with pots of 1,000 mosquitoes. He's sitting there with one of those bladeless fans from Dyson, which points out of the window. And when the iPad gives him a GPS reference points that he passes, he literally takes a pot, taps it on the Dyson fan, and the mosquitoes are blown out.
Okay.
It's a very good use for a Dyson fan, actually. I mean, I was thinking we might patent re-patent the fan as a mosquito release device, but I'm told that's not possible.
Okay, that's a shame. And I'm wondering, how big are the areas these mosquitoes reach when you release them?
Well, our mosquitoes are the same as any other, so they only fly as far as a wild mosquito. So mosquitoes will not fly further than 200 yards or 200 meters in their lifetime. Which means that if you get Zika, dengue, chikungunya, yellow fever, any of these diseases, you've actually been bitten by a mosquito which has been born, if you like, within 200 yards of where it bit you. So they're very localized. And that's probably one of the big problems with mosquitoes, is that mosquitoes don't travel very far, but humans do. And humans will go from country to country very rapidly, and the vector, this mosquito vector, is all the way around the world. So if you're in Malaysia and you're bitten by a mosquito carrying, let's say, dengue fever, you jump on a plane, you feel absolutely fine for 2 or 3 days, you land in Sao Paulo, you walk around, you're bitten by the same mosquito species, and you've then become a vector, and that mosquito is then carrying the disease and infecting local people.
Okay. And is your goal to completely eradicate these mosquitoes, or like clear them completely from an area?
Our goal is fundamentally to protect people. We're not after the mosquito. We have nothing against the mosquito. I mean, the one that actually spreads these diseases came out of North Africa. It's called Aedes aegypti. So like its name, it literally came from Egypt. So it shouldn't be in the US, it shouldn't be in Southern Europe, it shouldn't be in Latin America. So actually, if you got rid of it or eliminated it, you'd actually be restoring the environment. But our goal is just to protect people. So mosquitoes will have their biggest impact where you have huge concentrations of people. So our objective is protect people in Sao Paulo, protect people in Miami, protect people in Rio de Janeiro. And by applying our mosquitoes in the street, you're actually crashing the population in that particular town or city.
Okay, yep. And as you mentioned earlier, of course, I'm going to ask you about regulations because, yeah, you've released the mosquitoes in so many different places, and I assume the authorities ask you for completely different things in each one. What are the challenges you have found when trying to releasing the mosquitoes in the wild?
So the challenges are huge, really, because we're always the first company in any country in the world to say, can we release genetically engineered mosquitoes? And some countries will have regulation, others won't. Some will think they have, and they don't, or some will have regulation that actually doesn't apply. So I won't name the country, but there's a very large country, if you go west of Ireland, that that when we first said to the regulators there, can we introduce our genetically engineered mosquitoes to your country? Do you have regulation? They said, yeah, we do. Mosquitoes are an animal, and we have regulation on release of animals, which are GMOs. All you need to do is tag them in the ear, and you're off. And we said, well, that's a bit of a problem, because we want to release millions, and mosquitoes don't have ears. So they had regulation, we just didn't quite fit. So we've actually done an awful lot. We've had to work with regulatory bodies. We've actually carried out our own briefings to international regulatory bodies. We've carried out regulator training sessions around the world in conjunction with World Health Organization and others. So we've been really at the forefront trying to educate regulators, giving them a thought process as to how they can take normal risk assessment into the world of mosquitoes and what they need to think about. But each country is different. So in the US at the moment, although it will probably change, we're regulated as an animal drug. In Brazil, we go through a system which is a biosafety assessment first, and then you go to the relevant ministry that will regulate you commercially, but you do your technical risk assessment first. In other countries, the regulation is, again, different. You might go through the Ministry of Agriculture. Always very difficult, always quite challenging. But I think what you see now is that it's like in any area. Once one regulator can look at another regulator's assessment, they can see the dossier, they can see the approvals, and then they can actually adapt their own processes. And now, actually, we've got a recommendation from the World Health Organization to countries saying we actually think that this is something that countries should evaluate in order to combat Zika and dengue. So that's, again, a big help.
Okay. And besides regulation, I'm wondering, since you have a product that has the label genetically modified, have you faced any ethical objections to the technology?
It's an interesting one. Whenever you label anything genetically modified, whether you label it or somebody else labels it, you get a certain amount of controversy. I think what we try and do is start with the community in which we're going to be releasing. And I think over time we've become reasonably good at that. So in Brazil, for example, in Piracicaba, we have, we never ever turn down an interview, by the way. Even if a journalist says, I want to do a bad story on you, will you talk to me? And we'll say, yes, we will.
Okay, that's brave.
But what we do in Brazil, for example, we will do town hall meetings and invite the local population. We'll do door-to-door. We'll have little vans. In the north of Brazil, where there is really not much sort of local media, they even have these little vans going around with speakers on the roof saying, buy soap powder. So we've taken these vans, we've made a little song, and we've said we're coming to release genetically engineered mosquitoes, and they're nice ones, and that worked very well.
Okay.
We have little cages of our male mosquitoes, so that if you're a member of the public and you're shopping, there'll be an Oxitec stand in the shopping centre. You can go and put your hand in the cage of our mosquitoes, and you're not bitten. And actually, the name of the first product we have is OX513A, which is not a very good name. It shows that the science is better than the marketing. But when everyone said, what's the name of your mosquito, we said OX513A. And the press sort of said, we can't cope with that. So they actually named it the friendly mosquito.
Okay,
so
that's a good name.
We now have a name called Aedes de Bang, which means good or friendly mosquito. But that came from the press because they just thought our product name was terrible, which it was.
Okay, and so now that you've already been releasing some of the mosquitoes outside, you're getting good results. What are your plans for the future, short term and also long term?
So short term, so there's really one mosquito species which is sort of public enemy number one for dengue, yellow fever, chikungunya, and Zika, and that's this one called Aedes aegypti. There is a second mosquito which is a very bad biter, an unpleasant one. It's not a very good vector, it's not a very effective vector, but it still can transmit the same diseases. So from our point of view, we're developing that because then that's a sort of sister product. We're also, in the second form of our product, we're developing one where instead of just instead of a situation at the moment where all of the offspring will die, in the second product it will only be the females that die, so it's a sex-specific approach. And the reason we're doing that is to make a product which in effect is consumer ready. So for example, and we have this product now, it's going into trial in Brazil. So for example, I could send you it's regulation allowed, I could send you mosquito eggs, or you could buy them in Walmart. You could put them in a cup of water in your front garden, and just males would come out, and when they mated with the females, females would die. So you've got your own biocontrol. So that's extension of the same product. So we have a sister product and extension. And then we're very, very keen on working in Anopheles, which is the mosquito that spreads malaria. That's a goal of ours. The difficulty with malaria is it's a very difficult market to get investment in because it's partly Latin America, but it's predominantly Africa. Very difficult to convince investors that you have an investable proposition. So we have been talking to the major aid funders like in Gates, to say, look, now that you can see what we're doing with Aedes and you can see real field results, you can see regulators approving it, you can see people buying it, and it's effective, it's not just an experiment in a lab, why don't we go and do Anopheles? So, and really make an impact in malaria. So I'm hoping over the next few years that we get the green light and we get funding and we can have a go at that as well. Yeah, sure. The other thing we do is non-mosquitoes. I mean, we have similar challenges in agriculture. So the biggest competitor to man when it comes to food is insects. They like eating our crops, and either when they're growing or when they're in storage, and we lose about 40% of our agricultural production to insects. So actually, what we do at the moment, if you think about it, is we wait until a point when your growing crop in the field has got insects already attacking it, and then you go in with chemistry. We think it'd be a lot more sensible to go in before the insects come in and not have any insects. So why don't we just release our males in the crop before the reproductive population causes havoc? So we are introducing exactly the same technology in a wide range of agricultural species.
Okay, yeah.
So that should keep us busy for a few years.
Yeah, for sure. Okay, it's time to take questions from the public. Does anyone have any questions? Tom? Yeah.
Thank you. It sounds very brilliant idea. I love it very much. I'm just thinking ecosystems, and then considering the human being as a part of the ecosystem, and we live in a different ecosystem. What is the long-term effect of this approach would be on ecosystem? Do you have, or can you elaborate a little, clinical data or any evidence-based data on that, since you are running the company from 2009, sort of that?
Sure.
Yeah.
Well, the first thing to think about is what is the potential here? So every insect we release, every male we release, is going to die in a few days. That's just natural biology. The offspring are going to die because that's the effect of the product. So you're not actually putting anything into the environment that will stay there. And that's critical for us because we don't want to actually make any permanent change to the environment from the product we introduce. So then the question is, well, let's assume you have an effective impact. You know, how does that affect the insects that are in the wild in the area we're treating? Well, again, we need to think about what we do now. So in an urban environment, what we're actually doing, I mean that as society as opposed to the company, what we're actually doing is spraying or fogging or releasing a large amount of toxic chemicals into the environment to target one particular species that's causing us trouble. And what that's doing actually is we're hitting that one target, which often is resistant actually to that chemistry, but we're also affecting a whole load of other insects and taking out beneficial insects, non-target species, and impacting on a whole series of different food chains. So our approach is we're just going for the one species that's causing us trouble, and we're actually not affecting all of those other areas. So we think actually we'll have a very positive environmental aspect because what we're putting into the environment doesn't stay there, and we're exquisitely targeting the one thing we're after. So it's like a sort of sniper's rifle as against a blunderbuss type approach. The other thing to factor into this is that in many countries, actually this insect was not present, or was present, and then in the anti-malarial campaigns in the 1950s and 1960s, it was pretty much wiped out. So in Brazil, for example, in 1976, the government just said, we don't have this insect in Brazil. We've eradicated it. And that was obviously based on DDT. And DDT, as you'll probably know, is a fairly nasty, toxic, permanent, chemical. But of course, what happened is that as DDT was withdrawn, this insect has come back. So actually, you're looking at an environment where the insect has only actually been prevalent in such incredible numbers for the last 50 years. So we're not looking at an insect which is, if you like, indigenous to an area and critical part of the environment. It's an invasive species, shouldn't be there, and poses a big threat to man.
Any other questions, please?
Did you do any simulations on how much of the population would have to eradicate to actually break the spread of malaria and make it extinct?
We have, yes, and other people have as well. The interesting thing is that no one's ever proved this, bizarrely, because no one's actually been able to with chemistry, take the insect population down low enough to break the disease transmission. Now, if you look, so there are mathematical models. The best one is by a person called Dana Fox. So what Dana Fox did was look at the impact of human population, mosquito population, temperature, climate change, seasonality, and then the background innate immunity in the human population. And then he actually modeled, the level to which you've got to reduce the population of mosquitoes to break the disease transmission threshold. And it varies from place to place because those variables vary. But broadly speaking, as a rule of thumb, which is a terrible thing to say, but you're looking to try and reduce the population of mosquitoes probably by about 80% to really break the disease transmission threshold. And you've only got two reservoirs of disease. It's either human or mosquito. So it's about an 80% reduction you're targeting. Which is why with our mosquitoes, with our trials, we've reduced the population in every case actually by over 90%, because we want to make a point from a scientific point of view. And actually, from our point of view, we're not going to fail in a trial. I mean, unless something strange happens and we actually have to break the trial or some other strange thing happens. With our system, it's a numbers game. The female mosquitoes can't tell the difference to the males from ours, from the wild ones. So, if you have a very high population of mosquitoes, you'll just produce more of ours. And if you've got lower, you'll produce lower. So basically, our impact, our goal is the sort of the 90% level, and achieve that in about 6 months. And the variable from our point of view is actually how many mosquitoes do we need to release to achieve that, and do we have the capacity? Do we have the right factory size to get there? Then the other point I should mention is that with all our studies, what we've done, because we have a fluorescent marker, a fluorescent protein which is expressed in all of the larvae, we can be very accurate with our monitoring. Whereas if you're using chemistry and you're just charging around producing chemical fogs, you really don't know what you're doing. It's very difficult to monitor. You don't know how many mosquitoes are out there and you don't know how many you've reduced. But we can do that. We can release our males, we can look at the male-female sex balance change in the adult population, and we can look exquisitely, around the town, block by block, what the reduction is compared to untreated control sites nearby.
Well, we've run out of time, unfortunately. Thank you very much.
I was enjoying myself there.
Yeah, sorry, but we need the others to speak as well. Okay, thank you.
Okay, thank you.